Okay, so continuing this problem, looking at the bones and the correlation, we set up the scatter plot. We talked about the relationship. We discussed what correlation does and does not tell us. So now we want to calculate that correlation for these data, and does it agree with your description in part A? Okay, well, in order to calculate, we need this formula right here. Okay, that formula for R, the correlation. Is that a formula that you find on your formula sheet? Well, let's look. If we look at our formula sheet, we have the sampling distribution for linear regression. We look at the pieces, and that formula for R is nowhere to be seen. Right? I do not have this formula for R if I'm looking at this piece. Okay, and if I turn and I look on the front, there it is, right? My R, my Y hat, my different pieces, right? So these descriptive statistics for linear regression, here's where your equation is for R, Y hat, Y bar, and B. We're going to talk about those in other videos, but there is that formula, okay? Now, this formula, right, what this represents, the 1 over n minus 1 is essentially playing with the degrees of freedom, right? The x sub I minus x bar, that's saying that your particular x value minus the mean for your sample all over the standard deviation of your sample, and then times the particular y minus the mean of the sample y all over the standard deviation of the sample y. Okay, well, that means that for this we need to calculate our information. Go ahead and calculate then, right, for our information up here, we need to find x bar, we need to find s sub x, we need to find y bar, we need to find s sub y. Go ahead and do that. Pause the video, come back and check how that relates to substituting into this equation. So that computation of R, we found x bar to be 58.2, s sub x 13.2, y bar to be 66, s sub y to be 15.9. So we're going to have R equals 1/4, 1 over n minus 1 of, right, and we say particular x minus x bar over s sub x, particular y minus y bar over s sub y. Okay, and then I suggest kind of setting up this pattern. I kind of ran out of space, and you probably will too, but setting up the pattern and then filling in the values that you need. All right, so for this one's 58.2, so I'm going to fill out the 58.2 for all of these first. 58.2, all right, hard to see. Then 66, 66, 66, I know, hard to see, right? We want to make sure we set that correctly, and then in the denominator, 13.2 times 15.9, 13.2, 15.9, 13.2, 15.9, right? 13.2, 15.9, right? So that's kind of tough to catch. Now, of course, I can put that all in my calculator. And to do that, I just start typing in the items, right? And really on the AP exam, you're not going to have to write all of this out. You'll just be able to write a couple of terms to show you know what you're doing, or pick out from a multiple choice, you know, how to set that up. But we're going to continue this. All right, so I have almost everything typed in. Then the last one's alpha y equals parentheses 74 minus 58.2, close parentheses, parentheses 84 minus 66, close parentheses, 13.2 times 15.9, multiply that out, and I see that I get this 1.25. Now, I should recognize that if I get this 1.25, that's an R value that is greater. That's an R value that is greater than 1. So I know that I've made a mistake. Let's see if we can find the mistake. One way that we can look for the mistake, and like I said, it's going to be very likely you make a mistake if you try to do it this way. right? One way to look for the mistake is to know that pattern. I can just put that information into list 4, right? Now I could make this list 3, but all of a sudden, right, if this is x bar and this is y bar, and then I have s sub x in list 5, s sub y in list 6, there's nowhere left to put my data, right? But I do know that my information for each of the x's is going to be this list 1 minus x bar divided by s sub x for every one of them. So I put that in. Okay, so I have those values. Then list 5, I'm going to say is going to be, right, parentheses, list 2 minus 66 divided by 15.9, right? So the data points from list 2 minus 66, 15.9. So now I have that. Then in list 6, right, I want the product of each of those. So list 6 can simply be list 4 times list 5. So now I have each of those products, okay? Now, what do I need to do with each of those products? I need to find the sum of those products. So what I can do, and I'm going to just come back to list 3 that I had the 58.2s, I don't need that. So what I can go is second list, operations, do my cumulative sum, and I'm going to do the cumulative sum of L6, and so now I see that 3.9737. That's the value that I care about because that is the sum of everything that is inside. And clearly, right, if I had, we'll remember that 3.9737, that if I had looked at my piece, right, here, and I said, hey, I put everything in there, that if I said, well, if I took all of that and I said, hey, somewhere in there there's a mistake, well, I found the mistake already. That mistake was right there, that was a 6 instead of a 66. Right? So we know that that's the mistake, and some of you might have caught it when I did it, but it looks like I made that mistake more than once. And once again, that R value above 1 kind of lets us know that. Right? But I can come over here and I can say, well, if I deleted this term out, right, and I just put that in there, that's not the 3.9737. Right? The 3.9737, right? Take that number, divide by 4, that's 0.993425. Once again, where was the 3.9737? Stat edit, right? 3.9737, and then I need to divide that number by 4, right? Of course, we said that had I looked over here, right, and said, oh, hey, my mistakes were, right, in this one, I was missing a 6. And I think I had another one where I was missing a 6. That was the one over here. Right, that should have been 66. Right, I could put that, and there's that 3.9737. But that's going to be a lot harder to do than if you simply did all your work in the stat edit piece. Okay, a lot better. If you need to rewind the video and rewatch how we did that in defining what was in list 1, what was in list 4, that's very, very important to do. So in any case, right, that number divided by 4, because of the 1/4, is 0.9934 approximately, right? So we found, hey, R is 0.9934. Does it agree with our description in Part A? Well, this is a number very close to 1. And we said that there was a strong positive linear relationship. So the answer to that is yes, right? We're good. Right? Now, what is going to be considered strong? We're going to save that for another video, but generally if we're close to positive 1 or close to negative 1, that's going to be strong. Okay? Now, we need to be able to draw the scatter plot and find the correlation using a calculator. Make sure you have your diagnostic on. So, how do we do that? I'm going to come over here, I'm going to go to mode, right, and I'm going to make sure that my stat diagnostic is turned to on. It is turned to on there. Okay, I'm going to adjust the focus real quick because it seems to have gotten a little bit out of focus. Hopefully that's a little bit better. Okay, then, right, stat edit, my data was in L1 and L2. I can go to second stat plot, right, turn on my plots, right, and make sure that I turn it on. Okay, and then also if I wanted to get my linear regression, right? Calculate the linear regression, and I'm going to want a plus bx, right? So I'm going to calculate that linear regression, and I'm going to store my equation into y1. That was alpha trace to get there, alpha trace, okay? And I have my equation in y1, which is where I want it. Okay, that's my equation. Awesome. I'm going to come over here and calculate it. And notice my r squared, and notice my r, 0.9934 to 0.9941. Are those very close? Those are very close. Why is there a slight difference in the computation value? Well, that's our rounding, right? This 58.2, this 13.2, that 66, that 15.9, those were all slightly rounded values possibly, right? So that's why you see that little discrepancy between the R there and the R that we have there. And of course, we could zoom 9 for statistics. There's our data, there's our linear regression line, and that looks very similar to the data that we had before. Okay. Sorry for the long-winded video, but the little steps and where mistakes occur is very, very important concept, so I want to make sure that we discuss that information with you.